Alright, so in this video, we're just going to have one quick example. What this video is showing us is if I give you the graph, what rule made it? Let's create the piecewise function that actually made this graph. Alright, so for lack, it didn't write the color I said. I'm going to write this one in red, and then I'm going to actually write this one in blue. So, because. So first off, what I want to talk about is I'm going to treat each of these individually. And then I'm going to put them together as a piecewise function. So if we're just looking at this one, what I want to ask, I want to figure out what is the domain of this function in blue. What is this domain? Which x values does it exist on? As we read left to right, or as we do like a vertical line test, where do the x values start to exist? So as soon as this vertical line hits the line, oh, right there. But notice it has an arrow. And that arrow is pointing to the left. So the domain of this function starts at negative infinity because it's all the way to the left. And then we're going to keep going until we hit the end of this line. Boom! We get the end of the line right there. What is the x value for that point? The x value for that point is right there. It's 2. So we're going to start this part of our function at negative infinity, and it ends at 2. Now the question is, can it be 2? Well, we look, and we go, is that an open circle or a closed circle? It's a closed circle, so we can be 2. Then let's find the domain of our red function. So in the domain, well, once again, let's take our vertical red line. So is my red line started? No, my red line doesn't start until it gets there. Well, what is that x value? The red line starts here, and it starts at 2. So we start at 2, and then it still exists as we go to the right, and because the arrow means go to the right forever. Going to the right forever is positive infinity. I can never reach infinity. But the question becomes, where this graph starts, can I be 2? And that answer is no. So if we were looking at our restrictions, this is letting me know the domain x has to be less than 2, but because it's a bracket, it's less than or equal to. The one below it says x can be bigger than 2. It's a parenthesis, so no equal sign. So those are my 2 restrictions. Now we want to write the equations of the line. So let's write the equation of our line in blue. We write the equations of lines by saying y equals mx plus b. So in blue, we're like, all right, there's b. And let's count the slope. From this point where b equals 0 to any other point on the line. Let's go here. Let's count rise over run. Up 2 to the right 1, or to the right 2, that gives me a slope of 1. So my blue line has the equation y equals 1x plus 0. Nobody writes 1x plus 0, though. We only say y equals x. Now let's do the one in red. Well, this one in red, we're going to extend it out and pretend it has a y-intercept. So for the one in red, it has a b of 4 and slope of rise over run. There is no rise, all run, so that's a slope of 0. So when we were to write that, that would be y equals 4. All right, so let's write our equations now. Instead of saying y equals, we're not going to say it twice. We're only going to say it once. And we're not going to say y, we're going to say f of x because it's a function. And then we are going to list our functions, our blue one first, because that is the one to the most left. So y equals, and the rule is, it says x if Now we go back to blue. What is its limitations? If x is less than or equal to 2. You know, I could probably do this all in blue. If x is less than or equal to 2. And then the one in red, y equals, what does y equal for red? 4 if, what is its restriction? X is greater than 2. And then we wanted to write the domain. Well, what numbers can I plug into the function as a whole? I can plug into either one of these. So my domain is actually going to go from negative infinity to positive infinity, because no matter what x value I plug in, I get out a real y value. Now we need to find the range. The range is listing the output values from bottom to top. Boom. So if we look at our graph, instead of drawing a vertical line, you can do this with a pencil or a pen. We're going to draw a horizontal line. Up right there, it exists. It starts existing way down at the bottom of the graph. What's way down at the bottom of the graph called? It's called negative infinity. And then as we drag, go up and 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 up, we get to there. Oh no, we stop existing. That is the last point where this graph exists. And what is that y value? That y value is 2. So my range goes from negative infinity to 2. You can touch the 2, but not the negative infinity. And then there's one more group. So we're going to jump across from where we're not continuous, and then we start existing there again. What is that y value? That y value is 4. Does it keep going up? Nope. It just stays on 4. So after I get done with the bottom piece, I jump up to the top piece, and its range is all 4. Boom. Easy. Alright, so if you have any questions, make sure you jot them down and you come in with them ready to ask, and we will go from there. I hope everyone has a good one, and I will see you when I see you.